doing df.drop_na is going to create a whole new data frame, and we're just assigning that to a new variable and then take that. Um, okay, so we can also, instead of making a new data frame, we can just replace the old data frame. And in order to replace it, we just put the in place equals true parameter um, inside of the thing. So um, again, we import pandas, we read it, and then instead of assigning it to a new data frame, we're instead just replacing the old data frame, but using drop na. But um, yeah, this basically just makes it so that um, the df gets replaced by df.drop_na. So it's basically the same thing as saying df equals df.drop_na. Um, if you remember some stuff, like if you remember when we sort lists, you do like something dot sort. It's kind of similar to that. You don't have to make it equal to anything. You just call the function and it'll do it for you. Um, so yeah, just making in place equal to true inside of our parentheses of drop na essentially replaces the data frame instead of having to assign it to a new data frame and all that. Um, yeah. Um, okay. Replace empty value. So okay. Um, when we're dealing with empty cells, um, instead of deleting them entirely, another thing we can do is just replace the values with something else. So instead of an NA, we can put in another number or another word depending on what the situation is. Because um, if when we're sorry, when we're removing rows, usually the data sets are really big. Our data frames that we're working with are very large. So removing one or two rows um, shouldn't really have a big impact. But if we're using um, like a data set that's a lot smaller, so I mean, 32 is pretty small. It's not the biggest thing. So sometimes we can't really afford to drop rows. So that's where replacing the empty values comes in. Um, and instead of using drop NA, we're going to be using fill NA. And fill NA is basically just going to replace every single NA value with a 130. So um, if you remember, we go back to 18. If you remember, this at calories was an NA. But now we've replaced it with 130 because that's what the fill NA function does. We're replacing every NA with 130. And you can see, I mean, they say 22 and 28, there's a 130 here, and then over here in 28, there's a 130 here. So yeah, we're just replacing every NA with a 130. And of course, if you remember, the in place equals true makes it so that we don't have to call it to a different data frame. We can just say that it replaces it by doing it this way. If we were to try and like change it to a different value, so like 60 instead, and we're to run it again, you'll see that it replaces the values with that number. So 60, 60, 60, um, and yeah, it basically whatever's in this first argument is going to be whatever is put in here. And also notice that these are doubles, while these are just integers. Um, and that's because it will mostly just like follow whatever whatever like the data type of the column is. Like for example, well, I mean it doesn't follow strings here, but that's um, not entirely sure why. Maybe it's because of this, but here they follow doubles because the whole column is doubles, and then here it doesn't. Um, so yeah. Okay. Here. Okay, so here we're instead of replacing for every value of NA, um, we're going to be replacing it for only a specific column. So if you remember, there was this value over here. And if we were to just put like 130 into that, I mean that's a date. So it would be kind of weird to just have 130 or 60 as a date. So we can just prevent it from um, doing it for replacing the values inside of the date column by instead specifying that we want it to be in calories. Um, and yeah, we're just specifying the calories column of our data frame, and then we're just doing the exact same thing. Fill NA 130 in place equals true. So the only difference here is that we're specifying that it's the calories column rather than just the whole entire data frame, the whole data set. And we can do the same thing. We can replace this with like date, and then let's just give like random dates. So I guess a good one would be, oops, 2020, 12, 22. And then if we run this now, you'll notice that over here, it gives 2020, 12, 22, which is, and it doesn't give it for these ones because we specified the date column, which is this column, and it doesn't worry about the NA values in calories. So yeah, that's, oh wait, no, there's some more. Okay, so instead of a good way to replace empty cells, because of course we can't just assume the same value for um, every single value, because of course that would likely like put some skew in the data, like it would change the data like a bit too much. A good way to get some um, accurate data points is by using the mean, median, or mode. If you don't know what the mean is, basically you add up everything and then divide by the number of values to get the average um, like value. Median is basically like the middle value, like right in the middle if you were to order it from to increasing, and then mode's just um the value that comes up the most in that data set. So let's go here. Um so yeah, if you well it's already run. So of course we're only specifying calories because if we put it to date it would look weird. So let's look at 18, which was one of them. And you'll notice that gives 304.68, and same thing with 28. And that's because we're doing x equals df calories dot mean. Um, and as you might think it is, it basically df calories dot mean is basically just getting the mean of this whole column. It's we're specifying that we're in calories, or we're getting the column calories, and we're getting the mean of the column. And we're assigning it to x because it's going to end up being a number. And when we're filling the NA values, we're using X rather than any specific number because that's what our mean is. Um, yeah, you can also do it like it says here, median and mode. And we can try it here. We can replace this just with median, and if we run it, you'll see that comes up as a slightly different value. So last time we had like 304.8 or something like that. um, but now we have 291.2. And 291.2 should be in, yeah, right here. Oh, wait, no, that's from the other thing. Um, okay, well, 291.2 is going to end up being the median of our data set in the calories section. Um, and 292 is what they're going to end up replacing every single NA value with, just like we did with the mean. And we can do it again with the mode. Um, okay, this is interesting. Um, okay, I think the reason why this is happening is because there's either multiple modes or one of the modes is NA, um, which causes the whole thing to end up being NA because a mode there can't be or like in statistics, there's not usually multiple modes. And if you do have multiple modes or an NA as a mode, it ends up becoming it ends up not really working out. Um, so that's why we're having NA values when we're using mode here. Because if you see, we have 300, like another 300, we have two 250.7s, and yeah, I think it's just messing up the data. That's probably why. Okay. So yeah, that's the median. We went over that. That's the mode. Um, and yeah. Okay. So now we'll look at like the wrong format. So um, let's find an example of that. So like this 26. You'll notice that most of our dates are in like month, no, sorry, year, month, and day, and separated by forward slashes. But at 26 specifically, they just completely forget the forward slashes. So there, this isn't like a good data point, and it might end up messing with our whole data set because this isn't a normal like date that we have that we're supposed to have at least. So one thing we could do is just use to date time, and what that will do is it'll get whatever like it had and convert it to date time. Date time is going to be in year, month, day, with dashes separating them rather than the forward slashes that we had here. But what it will do is it will fix some of our data points. So, for example, over here, it fixes our 2020 12 26 data point because it realizes that that's a date and then puts that into this format. Um, and I mean, here we're using pd.toDateTime because um, we're we're doing we're doing that function on the data frame, or specifically this column of the data frame, the date column. Um, so yeah, make sure when you're doing to date time, you're using PD rather than just df.toDateTime, because that's not the correct usage. We have to do pd.toDateTime, and then the input has to be the column that you want it to be. And of course, you have to make it equal to the original column, or else it's going to, or else you don't actually change anything in your original data frame. Um, okay, so now we have this situation where we have uh, NAT, which I think is referring to like not a time or not a daytime or something. Yeah, not a time. It says right here. Um, and basically, we can't really do anything about that. Um, so we're just going to remove it. Um, and yeah, it's basically doing a similar thing that we did last time. We're using drop NA, um, specifying date, uh, and then of course we're replacing the original data frame. And you'll notice, yeah, it's just gone. This specific date is gone because we don't have a data point to put to it. So we just completely get rid of it using the drop NA function. Um, and yeah, okay. Sorry, I'm like, yeah, okay. We'll go to fixing wrong data now. So wrong data is different from wrong format. If you remember format, our values were like this, where it was the correct data set or data point. Just it wasn't in the usual format that we had, which was year slash month slash day. We just had a string of eight numbers. But a wrong data is more something like this, where um, we have 450 minutes in our data point or data set, and considering that everything else is like 60, 45, 30, it's very likely that this 450 is completely wrong or just like maybe a typo. I mean, they could have been putting 45 in there, um, and instead they just added a zero somewhere. Yeah, 450 minutes is 7.5 hours. I doubt anyone's like working out for that long. So, um, yeah, this is going to be a wrong data point, and we're going to try to get rid of it here. Um, so to replace values, we're going to be um, using the .loc function, or I guess not really. Is it a function? I'm not sure. To specify what like what specific row and column we want to be in, um, and we can just specify what we want it to be. So um, we what we're doing here, we're going down to row 7, so over to here, and then we're going to duration section. So this one, and if you remember, in our original data frame or data set, we have 450 at 7 duration. So that's the specific point where we want to change our value. And assuming that they made a typo and they just want to put 45, we're just going to replace that value with a 45. Um, so now the data set looks a little clean, like a little better, a little more accurate, um, because we got rid of that wrong data point. Um, I mean, yeah, this is so the dot lock is going to the first parameter that we put into it is going to be in charge of the row that we have, and the second one is going to be responsible um, for the column. So if I were to replace this with calories, it would go down to 7 and then change calories, so change this value instead of the value that we originally had. I hope that makes sense. Okay. Okay, so when we have much bigger data sets, we can't just like comb through each column, each row, and just check, oh, is this one correct? Is this one correct? Is this one correct? And um like we can't just like do that because there's too many values to look through to check if they're like correct or accurate. So instead, what we're going to do is we're going to use a for loop to go through um every single value and or I guess in a specific in this case specifically duration, and if it's greater than 120 we're just going to make it equal to 120. We're basically just putting a max limit on what duration can be. um, so for x in df dot index, if the location x duration, in this case 7 duration, is greater than 120, and if you remember, it was 450, so that's definitely greater than 120. We're just going to make it equal to 120. And if we had some other values over here somewhere, maybe here, that were also greater than 120, then those would also be set to 120. And we could also do the same for like calories, and we could maybe put like an upper limit of like 450. So if we were to change this to calories, um, and for some reason we want to change to 450, um, this will also put a max at 450 for these. So um, this was like 479 or something, but since it's greater than 450, we want to put a max at 450. So we're just stopping it there. We're stopping it at 450. We're making it equal to 450, so that like I don't know, for one reason or another. Maybe we need to do that for some reason. But um, that's an example of stuff that you can do using for loops and changing values. Alternatively, like usual, you can just completely remove the row. Um, Instead of dealing with the data, you can just completely remove it. So we're doing the exact same thing for f in the index. We're going through each row and in the duration column, and we're checking if it's greater than 120. Of course, most of the values are not greater than 120, so it's fine. But you'll notice that row 7 is completely missing. And that's because that's greater than 120. So now we're just dropping it and just completely getting rid of that whole row. So now that row doesn't exist inside of our data frame. Df.drop x, which refers to 7, because it's going to be 7 in the for loop when it reaches that point. And then, of course, in place equals true is going to make it so that we just replace the original data frame rather than putting it to a different data frame. So, yeah. Um, I mean, I guess I could do it for calories as well. If you remember, we had something with that was greater than 450. So we can just do that. And then you'll notice that our second row has just completely gone because we had like 479 point something on that, and that's greater than 450. So we just completely get rid of our row there. Okay. Um, so yeah, that's how you deal with wrong data. Last one, we're going to go over removing duplicates. Um, this is not always going to be necessary, but I mean, because sometimes there are supposed to be duplicates in data sets, but I mean, in this case, if we're like tracking like workouts and stuff, this is almost definitely going to be a duplicate row because they're on the same day, they're for the same time, you got the same like pulse and max pulse, you burn the exact same amount of calories. That's a really hard thing to do. So, um, this is most likely going to be a duplicate row, and we want to get rid of that. So, um, to deal with duplicates, first we'll have to be able to find the duplicates. So to do that, we can use a duplicated method, and that just checks for every single row and checks if that row has the exact same values as another row before. So we run this. Um, yeah, basically we get the data frame, we import pandas, we read the data frame, and then we just simply print df.duplicated. Um, and yeah, everything's basically false because there's almost no duplicates except for 11 and 12, if you remember. Well, it was 11 and 12, right? Yeah. Um, but something interesting you'll notice is that 11 is not true, while 12 is true. Even though both of them are duplicated, they're the same as each other. One of them is false and the other one's true. And that's because the way that this works is it's mostly just checking each thing and then storing it into a sort of like temporary database where if one of the values has the exact same as one of the previous values that it already has stored, it's going to give true. Otherwise, it's going to give false. So when it first sees 11, it's gonna say, "Oh, that's a completely new data set. We can just store that and then see, and then just keep moving on." Once we get to 12, though, it'll notice, oh, that's the exact same thing as one that I had before, more specifically 11. So then it's going to print out true because um, it's going to print out true because it's the exact same thing. So while they hadn't seen 11, if while they hadn't seen the data point by 11, once they get to 12, they've actually gotten it because it's from 11. But since 0 to 10, rows 0 to 10 haven't had it, 11 also comes up as false. Um, so yeah, that's the df.duplicated. It's just going to give a list of the rows and whether the row has is a duplicate or not. So now what we can do with that is um we can just drop. Well, okay. This is a way to find the duplicates. Here we can just simply replace or like drop the duplicates. Um, And you'll notice, yeah, 12 is row 12 is completely gone from here. And that's through the power of drop duplicates. Have a specific method to drop duplicates, and that's called drop duplicates. Um, and yeah, using in place equals true again. If you remember, that just replaces our original data frame. Um, Basically, kind of like a drop NA, but instead of checking for NAs, we're instead checking for duplicates. So they're very similar. Something to watch out for though is that while drop NA has no underscore, drop duplicates does. So make sure when you're dealing with those that you think about that, and make sure that you don't actually do the other one. Like, don't do a drop underscore NA or a drop duplicates by itself, or like with no underscore. So that's just something to note. And yeah, now we'll just go to our exercises. Okay, so pandas cleaning. First exercise, if you guys think you have the answer, you can try to put it in the Q&A section, um, like usual. So yeah, we'll just get started with the exercise. So insert the correct syntax for removing rows with empty cells. Um, if you remember, empty cells are going to be the NAs. So what would be put inside the blank here? Okay, yeah, I'm already seeing some good answers. Um, Wait for like 1 or 2 more seconds to see if anyone else wants to try. Um, okay. Um, yeah. So um, this isn't actually going to be PD drop NA. And the reason why we don't have PD drop NA is because we want to specify that we want it for our data frame DF. Um, so instead of PD dot drop NA, we're going to be using DF dot drop NA. And of course, we already have our DF written here, so we're just going to write drop NA in here. And if you remember, the drop NA function does exactly that. We're removing rows that have empty cells. Um, so yeah, it's not PD dot drop NA because we're specifying for our data frame. But yeah, otherwise everyone would be correct. It is drop NA inside of the blank. Okay, so now we want to insert the correct syntax for replacing empty cells with the value 130. So what would be the correct um, like thing to put inside here? I suppose. Yeah. Yep, that's correct. You guys are all doing very good. Um, Fill NA. If you remember, drop NA completely removes a row, while fill NA is going to instead replace those empty cells with our value that we specify in the parentheses. So yeah, df.fill NA 130. Good job. Okay, now we want to insert the correct argument to make sure that the changes are done for the original data frame instead of returning a new one. So we don't want to set it to a completely new data frame. We just want to keep our original data frame just with the changes that we have. So what would we put in the blank here to make that true? Okay, yeah. Um, those are Those are both correct. It is going to be in place equals true. So yeah, in place equals true is basically just allowing us to oops, what- in yeah in place. Sorry, in place, no capitals, equals equals true, and that basically just allows us to that's basically doing exactly what we want here. We just make it so that it goes for our original data frame that we have, and replaces it rather than like rather than having to throw it into a new data frame, which gets really annoying sometimes, especially if you have to do multiple checks. In place just makes it so that we don't have to keep creating new and new data frames that we're not going to use anyways. Okay, and last one, we want to insert the correct syntax for removing duplicates in a data frame. So this one's one we went over pretty um, recently, or I mean, I guess this was all recent, but like um, yeah, removing. We want to remove every duplicate inside of the data frame df. So what do we want to put in that blank? Okay, yeah, seeing some good stuff here. Yeah, that is correct. Good job. It would be drop duplicates, and good job remembering like the underscore as well. I don't really know why they did it this way, but like I think this is like the only function that we've or only method that we've looked at so far that has an underscore. But you guys did remember it, so that's good. That's great. But yeah, it's drop duplicates. That just removes every single duplicate inside of a given data frame. And yeah, um, so is that's all the exercises that we really need. Or not all the exercises, but like that's everything that we need to go over for cleaning data. Um, so um, we're going to move on to the next thing. And next thing is actually going to be me again. Um, and I'm going to be basically going over the packet, I think packet 3. So yeah, um, hold on, let me stop sharing and pull up packet 3. Um, Sorry, 1 second. Okay, hold on. Share my screen. Okay. Um, so yeah, we're just going to be going through packet 3, like we did for packets 1 and 2. Question, someone else will be doing the other 20. So, let's just get started. Question 1: The XYZ Organics Company needs a simple program that their call center will use to enter survey data for a new coffee variety. The program must accept input and return the average rating based on a 5-star scale. The output must be rounded to 2 decimal places. So basically, we have a bunch of code, and we want to have a print statement at the end. So which one of these print statements is going to be the correct one um, to do what we want it to do? Does anybody want to try this one? Okay, I'm seeing some differing answers there. Um, give like one more second to um see what if anyone else has any other ideas for this. Okay, I'm not sure if anyone else is gonna do it, so we'll just say the answer. So for this one, um, yeah, this one's specifically, um, we want to have we want to basically round everything to two decimal places, and and we're just that's going to be using like some form of string formatting. So um for this one specifically, we're going to be using I think it's going to be one, and that's because um we're going to be using um 2f for our um well, sorry, yeah, we're going to be having to use 2f for this one specifically, because if you remember, that's how we fix it um to two decimal places. Um and yeah, it's just going to be putting it to two decimal places. Um and of course it's not going to be the third one because we need the dot there to specify dot to f. We want it to be to the second decimal point. Um, but yeah, this one's going to be the first one. Um, yeah, good job to the people that were able to do that. Move on to question two. Okay, so next we want to just consider the following statements. And it just gives four print statements. So now we just want to find which of the above statements are true. So basically, we're just doing a bunch of string formatting and trying to figure out which will print to what. So how many of these four statements are true? Yeah, yeah, seeing some differing answers again. Again, I'll give it a little bit. See if anyone else wants to try answering that. Um, okay, not sure if anyone else is going to really um, answer this. Um, so I mean, I'll just go over it then, I guess. Um, okay, so let's just go through each of the statements one by one, and we'll just try to pick out the ones that are true rather than false. So, um, first statement. So we want to basically shorten this to 2 decimal points. Um, so because it has dot two f in the little curly brackets, and remember we're going to round. So um, when we round 123.456, because that's the only ones that we need to worry about, since we're shortening it to 2 decimal places. The 0.456 is going to round to 0.46, and of course we need the 1, 2, 3 at the beginning. So this first one is um, going to be correct. So now we know that first one is um, correct. So sorry, give me 1 second. Yeah, so the first one's going to be um, yeah, first one's going to be true. Okay, so now we'll look at the second one here. Doing the same thing, we want to specify to 2 decimal places. Um, and now we just have 123.4. Um, so if we wanted to specify that to 2 decimal places, um, we're going to be adding a zero because, of course, we want it to have a little thing at the end. So two is also going to be correct in this case. It's also going to run true. Um, okay, so we'll look at the third one. The third one that we have, we do 8.2f, and we have 1.45678. And for this one, it's going to end up just doing like a bunch of blanks and then um, a point 0.46 because that's we want to stop it at 2 decimal places. It's just doing a bunch of random and then 2 decimal places. Um, because of course, if we have 8.2f, we just basically want to we basically just want to get the first ones, or like sorry, if there's we want to go that far left, but like if there's nothing there, then we just have blanks. It's different with four though because we have a zero in front of it, which instead puts zeros in there, and that's also going to end up being true because of we just need to put a certain amount of zeros in order to satisfy our 0, 8 rather than 8. Um, but yeah, okay. So yeah, the answer is going to be 4 here. Um, yeah, we'll move on. We're developing a sports application, and our program should allow players to enter name and score, and the program will print player name and their average score. The output needs to be left aligned. If the username is fewer than 20 characters, well, we must put extra space to the right, and the average score has to be 3 places to the left of decimal point and one to the right. So like something 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 point something. So what print statement would we use in that specific situation to get our to get these specific parameters, or like to fit these specific rules, I suppose. Okay. I'm seeing um, a lot of different answers again. Um, so I mean, I guess I'll just go through it. Um, go through it again. Um, sorry. Give me 1 second. What is going on? Okay. Sorry. So, um, first thing that we'll notice is that, well, first let's look at average score must be three places to the left, a decimal point, one place to the right. That's going to refer to um, a four. Yeah, that's going to be referring to a 4.1 um, F, and that's just so that wait, yeah, I think that's correct. So, um, because if you remember 4.1 F, that fixes the decimal point such that we have like four things with one decimal place, and that's going to be something 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 dot something. So we can already narrow it down to two, and the only difference here is between the 20S and the 20F. Um, and here, this one's going to be referring to um, the little part before that. The left username must be aligned. Username is fewer than 20 characters. Additional space must be added to the right. Um, basically, we're specifically the second one. If the username is fewer than 20 characters, additional space will be added to the right, and that's going to refer to a minus um, or not it's going to be referring to the percent minus 20 the percent 20s, sorry. And that's basically just our way of doing that. That's how we're able to add characters if we need it. Like if it's like 20, then we just add more characters. So that's what the 20s is responsible for there. um, so uh, this is going to end up being one, I think. Or is it? I think so. Yeah. Okay. Consider the following code. Um, yeah, we have numbers, index, and a while loop. So to print 0 to 6, I want to print 0, 1, 2, 3, 4, 5, 6. What changes should we make to the above code so that it just does that? Because right now, it's not really doing. Um, and yeah, the while loop on the line 3 is going to be considered line 1, and then the if on line 6 is going to be considered line 2. So I'll give you guys a second to try this one. Okay, seeing a lot of good answers here. Okay. Um, sorry. Yeah. So the first one that we have, or um, that is going to be pretty obvious. So, um, the if statement right here. Notice that it has only one equal sign. So the way that we're going to fix that is we're going to instead make it so that we have two equal signs. Because if you remember, one equal sign is used for assignment, while the other one is more often used for um, sorry, it's more often used for what's the word? Comparisons. Sorry, I forgot the word. Um, so instead of using one equal sign, we're going to be needing to use two equal signs, like number two suggests. Um, and so yeah, we're going to pick number two as one of our as one of our sorry, I keep forgetting words. As one of our um options. Sorry. And in the case of our our possible second one, we can look at them real quick. Of course, number four isn't going to be correct because um, we can't make it go over zero, or else it's just gonna keep on going until infinity. Or I guess it'll just keep going. Sorry, not infinity, until nine, until the end of the list. Um, but number one is something that we're going to do because if you look in our while loop, you'll notice that it doesn't actually have a colon. And a colon is really important in a while loop because it shows that anything indented under that while loop is going to be used in that while loop. Um, or is going to be part of that while loop. It's going to be part of that while loop. If we don't have a colon there, it's going to mess up everything else. This stuff is not going to be considered inside of the while loop. So we're going to be clicking one as well. So we're going to be using one and two in this specific one. Yeah, I can see that most of you got two, but I mean one. It's just like one tiny thing, so it's not. It's understandable that that was like missed one. But yeah, it's gonna be one and two there. Okay. So another thing here, we are writing a Python program to validate employee numbers. The employee number must have the format DD, DDD, DDDD, and consist only of numbers and dashes. The program prints true if the format's correct, otherwise it prints false. So now we have that code. So which of the four statements is true about the code that we have in there? So I'll give you guys a bit to try out this one again. And then um, yeah. Okay. Not seeing many answers for this one. Okay. Um, I think I should try and probably speed up the process a little. So I will be giving a little less time, but yeah, I'll just go over it now. So, um, I suppose we can just look through each of these, and if none of these um, are, or I guess we'll look at the first two first, and then we'll look at the other two. So first, it's saying that it'll throw an error because because of the misuse of the split method. So if we look at the split method here, you'll notice that it's parts employee number dot split and then a dash. And that's not really a misuse of the split. So that should be totally fine. We're using we're using our dash as our splitter, and that's just a correct way of using the split method. So it can't be number one. So look at number two, digit. The digits are used in this if statement here, and those are used mostly correctly, it seems. Parts 0, 1, and 2 in the list. All of them are going to, we do want to check if DD is a digit, DDD is a number, and DDDD is a number. So there's no misuse of the is digit method here. So now let's check if it fulfills our requirement or not. So we can try to think of what the program is doing and see if it does what we want it to. So we have our input, we have our split. So it splits it into each part. We have DD, DDD, and DDDD. So now we have valid to check if it's false or true. If it has three parts, which of course it does need to be DD, DDD, DDDD. We need all three of them to be a thing, like exist basically. Um, we want to check if the first one has a length of 2, the second one has a length of 3, like third one has a length of 4. That's correct there. And we want to check if every single one of them is a number. And if all three of those are correct, we make it true. Otherwise, we make it false. So it doesn't really look like um, there's any problems with it. It does fulfill our requirement. So the answer here is going to be number 4. Okay. Question 6. You're coding a math utility by using Python. So we want to compute roots, and the function must meet the following requirements. A non-negative, return blah. If negative and even, we say it's imaginary. If it's negative and odd, we return that. So I'll give you guys a second to look at these. I don't really know how to put all of them in the same thing. I can try to like zoom out a bit, I guess. That should work for now. Okay. I'm gonna give you a second to do that. Okay. I'll just give the answer now because we have um try to speed it up. But here the I mean, first of all, we know that number 4 is wrong because it doesn't do the requirements correctly. If it's even, we're giving it the whatever what we're supposed to do for the odd, and vice versa. So it can't be number 4. Um, we know it can't be number 3 because it can't be checking for both of these, or else it'll run both of these while if it's like a positive and even number, which we don't want. We don't want a positive and even number to result as an imaginary number. So it can't be number 3. Number two and number one, the only difference is elif a mod 2 is equal or not equal to 0. And here we do want it to equal to 0 because we're filling the second like requirement where if it's negative and even, we return imagine its result is an imaginary number. So we want it to be equal. So it's going to end up being one, number one. Okay. Number seven. We're developing an online shopping application. Consider the code, blah blah blah, to get 5 as discount percentage, which the following input should be provided end user. Um, so yeah, what input basically uh, do we want to put into your five? Okay. I'll just go over the things now. Um, okay. So for this one, um, you'll notice that our discount percentage is originally 3, and we everything that this is doing is adding something to our discount percentage. So in order to get 5, we want to add 2 to our discount percentage. So we're going to want to trigger our else statement in here. So um, in that case, we know it can't be Monday, we can't put Tuesday, we can't put Saturday, and we can't put Sunday, which just so happen to be 4 of our 5 values in here. So it's going to be whatever our last one is, which in our case is number 3, Thursday. So yeah, good job. I saw some people got it right. We get it right. So yeah, good job. Okay. Question 8. We are developing a gold loan application for XYZ company. We have some code for which of the following user input, interest rate, which of the following user inputs will interest rate be 12? So I'll give a second or so to do that. Okay. Um, so yeah, I'll just go over it. I can see, yeah, this one is going to be number 2. That's because we want to have an amount that's between 50,000 and 100,000, and the only value here that works is going to be 50,001. Otherwise, we're going to get a completely different interest rate. Number 9. We're developing an application for leave approval in XYZ company. Oh wait, no, this is skipped. Never mind. Sorry, I think this one we're supposed to skip. So let's go straight to number 10. So question 10, consider the following code, blah, blah. Which grade will be printed to the console? So let you guys try this one. Okay, I'll go over this stuff now. I'll go over the thing now. Here, basically, we're gonna get the average of them first. So first, let's do that. 30 plus 40 plus 50 plus 45 plus 50 plus 100. I think that is um, 120 plus 150. That's a 270. Um, 315. So here we're going to have 315 as the sum, and then we have to divide by 6, of course, which is going to give us around like 50, um, like a little bit above 50, like 52, 52.5. Um, so our average grade is going to be 52.5. And if we look at each of these, it's going to be at key 3. So our grade is going at for key 3 is going to be C. So it's going to be number 3, C. Um, yeah, we'll move on. Number 11, consider the code that which of the following cases will the result value become 9? So yeah, I'll give you guys a second to do this one as well. Yeah, this one's a bit of a hard one. I understand why people don't want to try this one, but it might be. Okay, we've gotten a few answers. Um, yeah, I'll just go over it now. So here, um, we can just go through each of them. So first, result equals 3 if none else a over b. One way we can check for these really easily is we can just check if either of the values are equal to 9. If none of them are equal to 9, the value can never become 9. So um, we can just check if either the value for before the if and then after the else, if either of them are not or if none of them are 9, then we know that value can never become 9 from that. So a over b, 12 divided by 4, that's 3. So this one's always going to be 3. um it's not going to be 1. Second one, we want s dot find is going to find our first case of the of not in s. So one, two, three, four, five, or sorry, I guess that's zero. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The first case of not is at 9, so that could be a possibility. At right hand, it's going to go all the way to over here. Um, I counted this earlier. This goes all the way up to 33. So yeah, this can never yield 9. And same here. If it's equal to 5, or else it's 6, so that can never be 9. So it has to be number 2 here. This one's also skipped, it seems. Skipped. Okay. Number 14. We have some code. Consider the code. And what's the result of the code once we do this? Or once we put our code in, I suppose. Okay. I'm seeing a lot of the same answer. I'm seeing a lot of twos. So let's see if that's correct. Consider the code. We have 10, 20, a list of 30, 40, and a list of 50, 60. So originally our count at 0 is at 0. And for every value in L, we want to check if the type is a list. So 10 is not a list, 20 is not a list, 30, 40 is a list, and 50, 60 is a list. So there are two lists inside of our list. So since every time we have a list, we increase the count by 1, or we increase count by 1, that's going to be number 2. It's going to be 2. So yeah, 2, number 2, yeah. And yeah. Okay, 15 is skipped, 16 skipped. Okay, 17. Consider the code. We have this. What is the result of this code if we were to like run? Not saying much, but I do want to try and um, speed up this process a little so we don't like I don't really squander anyone else's time. So I'll just go over this for this one. So here we have basically what this code is doing. If t1, so every value of t is in D, and remember we're only going to be checking for the keys. If it's in D, we're going to not worry about it. If it's not in D, we're going to add it to result. So 2, 4, 6 are all in D, but 8, 10, and 12 are not. So we're going to be doing 12 plus 10 plus 8 plus 1 because our result is originally at 1. And that's going to equal 31. 31. Sorry. So number three. Um, okay. 18. Consider the code that um and what's the result of the code that we get from this, basically. Okay. I'm just gonna go through this one. So, originally we have v set to basically a non-value, or I mean, it doesn't really matter in the first place because we're going to be going through values, and then for each list inside of that, we're going to be looking at the elements. So for the first list, well, okay, first we'll figure out what this does. This basically just gets the minimum of every single value because if element is less than the current v, it's going to be equal v is going to be equal to that new element. Otherwise, it's not going to do anything. So this code is basically used for finding the minimum. And you'll notice that the minimum for both of these actually are both one. Um, and the way that the v is set up, our result is going to end up being one. So number three. Kind of weird how they switch them up around. Why didn't they just make it like one, two, three, four? Anyways, question 19. Consider the code that. What result do we get from our code here? Okay, I've seen one answer here. Number one. So we'll look see if that's correct. See if that's correct. So yeah, first we have define a function get names with names from five different names inside of a list. But when we return it, we're returning only the names from the second position onward. So that's going to be Chinny, Vinny, and Pinny. And with update names, we're basically just going to be getting the first three letters in every single name. So Chinny, we're getting CHI. Vinny, we're getting VIN. For Pinny, we're getting PIN. So it's going to end up being, so when we return update names of get names, we're going to get Chi, Vin, Pin, which is going to be the first one, number one. So yeah, you were right. Good job. The last one that I'm going to go over, question 20. Consider the following code, and blah blah. What should X be replaced with? I guess just to print the following code: chicken, mutton, fish. What would X be replaced with there? really seeing any answers, so I'll just go over it right now. Maybe some of you are confused or something. So, yeah. First code is basically with any of these like values is basically just responsible for appending our first value into basically the list that we have after. So list.append and return. And you'll notice that you'll notice two specific things that give away the answer. Number one, we have list.append, and second, our final print, like the thing that we have to print at the end, is a list. And um, since the thing we have to print at the end is a list, and also dot append is only allowed to be used on lists, because we can't change tuples and we can't really append something to a set. Um, and I mean none. You can't really append to a none. Um, we're going to be using a list which has square brackets, so it's going to be number one. Um, so yeah, that's number 20 is number one. Um, so yeah, that's my portion of the first of packet three. And um, I believe uh, Baron is supposed to be going over the second half, so I will let him do that.
Yeah, just give me one moment and I'm gonna go ahead and start sharing my screen. Sorry. So it looks like I was muted, but for this problem, we have code which says that we have a function of f1, and in f1 we have two parameters x equals 0 and y equals 0, and we return x plus y. So which of the following method calls are valid? Which one of these is going to be valid? And remember, guys, if it has squares, that means that there might be more than one answer. Just so you guys know. Looks like everyone that is replying has replied. Make sure you guys are, giving me answers, even if it's a guess. A guess is better than putting nothing at all in the chat. This is how you guys are going to learn. So yeah, make sure you guys are responding in the chat. It's okay if you get it wrong. That's all part of the process. But yeah, to go over this problem, so the answer is actually going to be one, two, and three. And the reason for this is if we call one, right? If we call it, if let's just say A because we're dealing with numbers here. If we call A, then that means that we return 0 plus 0, okay? And that's going to be valid. If we do this, it's going to return the string 10 plus the string 20. So it's going to return 1020. And then if we do the third one, it's going to return 10 because 10 plus 0 is 10. And then finally, for the last one, this will not return a result and it will actually give an error because right now we're trying to add a string to a number or a zero. So that's unfortunately that one is not going to work. Okay. So that is question number 21. And okay, for question 22, where it's also very similar. We're considering the following code where we have a function f1 again, and the two default parameters are x equals 0 and y equals 0. And we are returning, this time we're returning x times y, okay? So remember guys, even if you're guessing, just please put something in the Q&A chat, just so I know you guys are at least trying. And yeah, leave you guys to that. Okay guys, and make sure you guys are submitting your answers in the Q&A. We'll be going over it shortly after everyone submits their answers. This one is pretty similar to the one above, so at least just try. It's okay if you get it wrong. Okay. So we'll go over the problem now. So the answers are going to be 1, 3, and 4. Okay. So basically, it's returning x times y, right? Whatever that may be. So if we do the first one, it's going to have the default values. So it's going to be 0 times 0, and that's going to return 0. The second one, you can't multiply two strings. So for this one, it's just going to give an error. So 2 is not a right answer. Okay. And then for 3, 10. Basically, if we give 10 for x, then it's just multiplying 10 and 0, and that's a number, so it's valid. It's going to return 0. And then lastly, for this one, now you guys might not have thought that this was a correct answer, but it actually is. If we multiply this, if we multiply a string by an int, it will return that string, like whatever number amount of times. Okay. So, for example, if we did the string 10 times 0, it's going to return nothing. Okay. Just an empty string. And if we did the string 10 times 2, it's going to return 1010. So, yeah, that's going to be the answer for this one. It's going to be 1, 3, and 4. Okay. And remember, guys, if this is confusing, make sure you guys are leaving questions, right? And our teachers will get back to you guys. Okay. So moving on. Oh, we're skipping this one, and then for this one, okay. So we have this code. We have numbers, and we have a bunch of numbers in numbers, right? We have a function called find numbers where we sort numbers, and then we have to return um, the first and the second to last, or the last thing in numbers, right? So the first number and the last number is what we're returning, and we have these two lines, right? So low equals find numbers and high equals find numbers. To print out 10, 100 to the console, which of the following code we have which of the following code we have to take at line 1. This is kind of worded weirdly. um, but it's just basically asking, what do we have to put at line 1 to print out 10, 100? That's basically all it's asking. So yeah, you guys can go ahead and try to solve this one. Okay. Just waiting on a few more answers. Once we get like two, three more answers, I'll go ahead and reveal the answer. Okay. So looks like that's it. So to Alicia and Jesse, great job. You guys got it right. So it's going to be the second option, which is print low of 0 and high of -1. Basically, find numbers. Okay, low and high are going to have the same value. It's just that um, we're printing out different parts of the values, right? So for example, for low, what's going to be stored is 10 and then 100. And so basically how this works is we sort this array. So it's going to go ascending order. And then once we sort it, we have the one at position 0, which is going to be 10. And then we have the one at position at the very last. So that's going to be 100. Okay. And so that's going to be 10 and 100. So it's going to return 10 and 100 to low and high. And then in order to print out 10, 100, we do low of 0, high of -1, right? This is not going to work. Obviously, it's just going to print out the data type itself, or the low itself and high itself, not the specific value. This is not going to work. This is going to print out 110. And finally, for this one, low of 2 does not exist because low only has a length of 2. So index 2 does not exist because that would be at the third thing of low. So yeah, that doesn't this doesn't work. It gives us an error. Okay, this is going to be the last problem, but we have this code and we're trying to see what the results might be. Take a look at the name of the program that gives you a big hint. FibSeq is short for Fibonacci sequence. And this is going to be the last problem. So hopefully I can get, at least 5 responses, guys. It's been, um, I've seen Shedrack, Alicia, Jesse, for the most part, and then Oscar as well. And Nice Martin. You guys are the only ones that I've seen replying so far. So thank you for that. If everyone else, if you guys could also type your responses in the chat, it's not too late. We're not gonna say something because you didn't put responses until now. We just want you to try and we want you to learn. So yeah, just try to guess what the answer might be, and I'll give you guys a few minutes to do that. Okay. Good job, guys. So the answer is one. So basically, what this program is doing is it's going to generate Fibonacci numbers. So if you don't know what the Fibonacci sequence is, basically you have two numbers, right? And then you're going to add them, and that's going to become the third number. And then you do the same thing with the latest two numbers to get the newest number of the sequence. Okay, you do that over and over again. So we first start here, and we're going to do for I in range 7, right? So we're gonna do um, 0, right? Zero first, and that's gonna return 0. And then we do 1, right? 1 is going to return 1, as you can see here. And then we do 2, right? So we're going to basically this is recursion. So what's going to happen is it's going to add n minus 1 and n minus 2, right? So if it's 2, it's going to add f of 1 and f of 0, and it's going to put that in here. And then if we do 3, it's going to add f of 1 and uh, f of 2, right? It's going to add those two together, and then it's going to output it. So this is recursive functions, right? It's just going to go over and over until it eventually reaches one of these, right? And then it's going to work its way back up. So yeah, this is just going to return the first 7 Fibonacci numbers. And so that's 0, 1, 1, 2, 3, 5, 8. Okay. So that is all we have time for today. Thank you guys so much for listening, and we will see you tomorrow. Yeah. Okay. Bye, guys.